and welcome to Disruptively Useful, the web series I just made up where I try to teach you how to build disruptively useful stuff. Today, I'm going to teach you how to 3D print with recycled plastic using a machine I call the trash printer, which is operating right here. The neat thing about the trash printer is that it is a 3D printer that prints directly from recycled trash flakes instead of processed filament. So you can just shred up any kind of trash. I'm currently using polypropylene, which is number 5, which is one of the most common recyclable plastics. And these used to be old test tubes, and I have them all shredded up. And you just feed them into this hopper here, and it's like a little funnel. And a auger pushes the material down through a heated tube, and this gantry moves it around and makes 3D printed objects. I've been working on this project for a couple of years now, and I just made this. This is a 3D printed out of trash mushroom lamp that I'm going to be raffling off to anyone who supports my Patreon before the end of the year. My Patreon is patreon.com/disruptivelyuseful. So if you want to win this, you can support this work and potentially win a mushroom lamp. And today I'm going to show you how to build the extruder portion of this project. This project is has 3 parts. There's the extruder part, and then there's the gantry part, which is the robot that moves it around. And you can use typically this is a machine that's designed for CNC cutting wood. So any large format CNC router that has a couple of inches of Z travel can be made to work in this way with this extruder. But not everyone knows how to do that, and so I'm going to start by showing you how to build the extruder head, which you can use with any CNC printer or gantry if you know how to do that. And then if you don't, I'm going to teach you how to build this particular gantry, which is called a mostly printable CNC. It's a semi-open design by V1 Engineering, and it's a really low-cost, easy-to-build, 3D printable gantry. And then in the final version, I'm going to show you how to do all the wiring and all of the software to actually get it to print stuff. So today we're just going to focus on building the extruder. And the extruder is designed to be low cost and easy to make out of readily available materials or easy to fabricate parts. So the whole design is based around just parts that I could find at a hardware store. I work at a hardware store, and stuff that is readily available at Home Depot or ideally a local hardware store means it's accessible to a lot of people and usually for low cost. I actually found this plumbing fitting at a used building materials store for $1. And if you got it new, it would be like $4 or $5. So this is a 3-inch PVC plumbing Y. This is 2 1/4 inch by 8-inch bolts, 2 1/4 coupling nuts, 2 2-inch 1/4 hex nuts, 2 1/4 wave nuts, a 1/2-inch pipe flange, black pipe flange. These are an array of pipe fittings that I've used in order to get different nozzle sizes. I'm trying to use very accessible parts. So for example, this is a 4-inch, 1/2-inch NPT, 4-inch long, 1/2-inch diameter NPT plumbing fitting from Lowe's, stainless steel, going to a reducer that goes from 1/2 inch to 1/8 of an inch NPT to a hose barb that ends up being a 1/4 inch. And this one is a 5-inch long brass 1/2-inch pipe with a compression adapter that goes from 1/2-inch NPT to 1/4 inch compression with a 1-inch length of 1/4 inch copper tubing. This one is a larger air hose fitting that goes directly from the 1/2 inch to a hose bar. And this one is actually a PEX hydronic heating or water fitting that goes from the pipe to the coupler to this fitting. And so I encourage you to play around with what seems interesting or workable to you. There's a lot of experimentation that can be done here, but of course we're just going to focus right now on what I know works, and then once you've got that going, you can start experimenting from there. Okay, so keep going with the parts here. We've got a screw-in high-temperature thermistor. We have a hot end, an aluminum hot end. This is the same hot end that is used for typical 3D printer nozzles, and we just have to modify it slightly for the larger nozzle. This is a 24-volt barrel cartridge heater, DC for a typical 3D printer. These are some connectors. Your connectors may change. I'm using Anderson power pole connectors, but a number of connectors will work. It kind of depends on what you have and what you like. So we've got a DC one and an AC one. This is the second thermistor. This is just a simpler one. It doesn't screw in. It just sort of slips in. This is a 300 watt, 120 volt, about 1 inch diameter barrel heater. This is a 3/8 inch wood auger. Very typical. You can find these at most hardware stores. A 12 millimeter plumb coupler, shaft coupler. And then you'll need a couple of wire nuts for your connections. You'll need these laser cut spacers. You can find the files for these on Thingiverse and on Hackaday. And all of these parts are really easy to cut. I cut them with a laser cutter with a Glowforge. And these hold the pieces together. So you will need access to a CNC cutter or a laser cutter. You can 3D print these parts, at least the top parts, but these ones are going to be in contact with hot metal. So actually wood is kind of an ideal material because it doesn't get soft and the heater doesn't get so hot that it will melt. So wood is a really good material. You can make one of these with a hole saw and just some woodworking tools. If you don't want to do the laser cut route or you don't have access to a laser cutter, it's just faster. But you can find these files online and use them as a template to use what you have around in order to do that. This is a laser cut adapter that I made. I had a really hard time figuring out how to go from the stepper motor to the shaft coupler to the auger. And so I just laser cut these adapters that go from the 12 millimeter shaft coupler to the correct hex size for the auger. And then I think I did the one thing that I forgot to mention here is this stepper motor. This is a NEMA 23 5-to-1 planetary geared stepper motor. So it has a gearbox in here that slows it down, ups the torque, and helps it push the material down. This is sort of the minimum viable powerful motor that I've found that will work, and it's still kind of pushing it. It skips sometimes. I wish it had a little bit more power, but it definitely does work. And so these are about 70 or 80 bucks on Amazon, and this part alone costs about the same as everything else together. So the whole bill of materials here should come in at under $150, and let's get building. Oh, so, of course, before you start building, you need to have some tools on hand. It's designed to be built with relatively simple hand tools and power tools, things that people tend to have. But you'll need a hex wrench set, a 1/8 inch drill bit. It's the one size up from a 1/4 inch. I believe this is a 9/32 drill bit. A 4 millimeter tap. A set of locking pliers or adjustable wrench. This is a Nipex adjustable wrench, and this is really nice because you can use it as a vise. I recommend these, but they're kind of expensive. Any vise grip should work. And a ratcheting nut driver with a 3/8 inch nut. And that's about it. So, the first thing you want to do is assemble the bottom assembly. There are two parts of the bottom assembly. This goes from the pipe flange, which will hold the barrel in place, to inside of the plumbing fitting. And then there will be two of these bolts that come up through it that will hold the whole thing together. So So the first thing you can do is, and I'm missing a spacer, so I'm going to step off camera. Need this one. So first thing you're going to do is thread the long bolts through each of these holes so that they all stay together. These are the 8-inch quarter 20 hex bolts. All right. And then there's this piece. The final piece in the bottom assembly is made with hex shapes cut out in it, so they fit these heads just perfectly. And that will space it out so that this can go on top. We only use 2 bolts for either side, and I found that's sufficient. So now, once you have these nested in there, you put the pipe flange on top of it, and that keeps those from falling out. You take the 2-inch quarter 20 bolts and you put them into these sort of slightly smaller inner holes. And again, the flange here, or the spacer, will hold this hex nut in place so you can tighten it from the other side. So you put that down like that. And that lets you attach this pipe flange with these quarter 20 wing nuts. And I like those. Doing it this way makes it so that if you ever need to take this off for whatever reason, which let me tell you will happen, it makes it just easier and quicker to do. So now you have this assembly, and it's not going anywhere. And you can take one of these assemblies, and you can kind of pick which one. I think I'm going to go with this one. 4-inch stainless steel, 1/2-inch MPT barrel. I think 4 was a little bit on the low end. I would kind of go up to 4.5 or 5, and I'll get to why in a little bit. But you're just going to screw that in there like that. And you don't need to do this any more than with your hands. You don't need to use a tool to tighten this because the plastic isn't molten up here, so it doesn't really matter. It just needs to be secure enough that it doesn't unscrew. This connection needs to be a little bit more secure. I recommend you use a tool like this to tighten that down. This one's already tightened, so I'm not going to do that. So now you have your whole bottom assembly, and you can feed that up through into the plumbing fitting. And now you have these bolts coming up that you can get to line up with the top assembly. Top assembly, you've got your motor, and you've got these ring spacers that will go around the body, this cylindrical shaft of the motor. And then you can use 2 or 3 of these. These spacers, you can use as many as you need, and you can use it to modulate how far the auger is pushing down into the barrel. You really don't want the auger to be going all the way down to where it's getting melted, because once the plastic is melted, it's a lot more viscous. It'll put a lot more back pressure on the motor. So you really only want the auger to go maybe an inch or so down into the extrusion barrel. It's just to catch the material in the hopper and move it down into the barrel so that that material is what creates the forward pressure on the melt zone. So you can use these spacers to modulate how much space there is there. But I use 3 of them. 1 is probably the minimum necessary. And then you've got this one that couples to this motor plate here with 2 4mm bolts. Again, I'm going to step off camera because I forgot those. Those go in here. You screw them on to the motor. You can sort of start them with your fingers, and then once they're in there, you can screw them down with your hex wrench. I only use 2. There's holes for 4. 2 has been fine for me, but if you want to use 4, go for it. All right. So now the motor is hooked to these spacers, And these will make it so they sit perfectly inside of the plumbing fitting. So I've got to make sure these holes line up. There's one. All right, so all those holes line up, and hopefully, I always forget this step. So the next step, before you connect the top to the bottom, you want to put on the auger. And so we'll take this plumbing fitting, shaft coupler, and we'll tighten it down onto the shaft of the motor. Again, this is a 12 millimeter. And if you have any clever ideas of how to do this in a more elegant way, I am all ears. This is the best way that I've found so far. So now you've got that shaft coupler on there, and you can put these little wooden spacers that fit the plumb coupler on there. This will sort of work down into the coupler, hold it nice and tight. And I like to, you don't need to do this, but if you can get a small magnet, I have this small magnet, and just stick it to the end of the drill bit, that will hold it to the metal of the shaft, and it just makes it a little bit more, less likely to fall into the shaft. Once you have material in it, the screw motion will actually push the auger up a little bit, so this is really just for setting it up, but you want to stay in there. It should press fit, but if you have a little magnet, it kind of ensures that it will stay in there. And so you can then press it into that. So now you have your top assembly with the screw. All right. And if I've done things correctly, you should be able to get this to line up with that. There we go. So now it's mostly connected. These laser cut parts make it very easy to do that. And then you'll take these these are 1/4 coupler nuts. They're not just regular nuts, although you probably could use those. These ones are nice because they're a little bit thinner and longer, so they're easier to get down in here. And so you can sort of start them by hand. And all these are going to do is keep pressure against, it sort of pulls the two plates together so they hit these two flanges on the plumbing fitting, and that holds the whole thing together. And once these are tightened down, it will keep the whole thing from rotating or doing anything crazy when the motor is under tension. So start those with your hands. You want to make sure that the two bolt holes are arrayed in such a way that they're not blocking the passage of the material through the hoppers. You want it to be that way. All right, and then we'll take the nut driver, the 3/8 nut driver, set it to tighten. We'll just tighten these down. So now we have our mostly assembled extruder. So now we have to do a little bit of work on the wiring and the heater systems. And this is the part that requires the most fabrication of this build. I've tried to make it as easy as possible with readily available parts and using tools that people mostly have access to. And but the one thing I haven't been able to get around or design around, again, if you've got brilliant ideas, please jump in. But what I do is I take, this is an aluminum hot end block, and you can get these for very, very, very little on Amazon. They're made for typical 3D printers. And there's this threaded hole here for the nozzle. That's usually where the filament feeds through. and then there's this hole here for a barrel heater. And so by modifying this, I can get one of these to slide over the nozzle. This is one that's already assembled. And it will slide over around the fitting, and then that gives you very precise temperature control right at the tip, which is really important for adhesion and good flow and all of that good stuff. So I'm going to just put this into these grips. These are very high pressure exerting grips, and I'm going to not do what I said that you should do in my documentation, which is you should definitely use eye protection, but I'm just going to show you. You take this, and that was with the 9/32 bit, and that just widens the hole in there so it will fit around the hole there, or the nozzle. And then you're going to need to change your bit to the 1/8 inch bit, and then you're going to take the same hot end, and you're just going to make a little bit of a hole. Sometimes there's already an existing hole, but you can make an existing hole down into the nozzle hole that's 1/8 inch, so that you can tap it and screw it around the nozzle to secure it in place. So, finally, you're going to take, this is a 4mm tap. I think it was like $7 at the hardware store. And you just put it into that 1/8 inch hole that you drilled, and you screw it in. If you get some resistance, you pull it back, screw it in, pull it back, screw it in. And what that will do is cap out the hole with a 4mm, so you can screw in a 4mm bolt. Let's see if I can demonstrate. 4mm bolt. This 1/4 inch or 9/32 hole that you drilled out allows it to slip over the 1/4 inch nozzle, and then this 4mm hole that you drilled allows you to put in a tiny little bolt that you can just screw and tighten with your fingers, and that keeps that aluminum hot end in place. So once that's in place, I'm going to do the rest on this bit, not this bit, because I think you get the idea. So then you can take your 24-volt DC barrel heater, and you can just slide it in there. There will be a bolt here that you're going to want to tighten down. You'll get the idea there. And then you're going to take your barrel heater and you slide it down. You can also, if you've already put it on, you can slide it up and over. And if you're using 1/2 inch barrels, 1/2 inch fittings, this will tighten very nicely around that. So you want this to be as far down as possible, right there towards the nozzle, so that there's enough space here that this can act as a heat break. And then you're going to, here, take this off for now, slide this up around the fitting. Let's see if I can get it to do like that. Stays in place. And then you can take the slide-in thermistor, and this one, mine fits right in here. And then you can just screw it down and tighten it. So now you've got that going. And then this is a screw-in thermistor that has a barrel connector or a small screw thread that's made to fit this type of hot end. All of these will be pre-tapped with these small little ports that you can put this thermistor in, whichever one works. Any of them is fine. The one closest to the nozzle is probably best, but choose whichever one makes sense. So now you've got your tip thermistor, your tip heater, You can slide this, and then this is your sort of bulk heater and your bulk thermistor. You can slide this over that. You can tighten it down, and now you've got your final extruder assembly. I did this all on this barrel and not this barrel because I realized that this is a different nozzle and it's slightly bigger, so I would have had to use a slightly bigger drill, which I don't want to do right now for time purposes, but you get the idea. This goes on there, and then I just use these wire nuts. I'm going to try and do as much of this build with wire nuts as I can because they're simple and they're effective. But you can just connect the heater with these wire nuts. There you go. There's that. And then the DC heater already has a fairly long cable, but you can also wire nut onto here. This is DC, but it doesn't matter what the polarity is because it's just resistance, so it doesn't matter which one is black and which one is red. With that, you've got your extruder ready to go. The one last thing you can do is you can take your bigger drill bit and you can take this PVC fitting. If you drill a hole right here, right underneath this line, little offset from this circle, that lets you get a tool in here and undo the shaft coupler. If you ever need to take the whole thing apart, it's just a little hole that gives you access to the Allen key that's on the shaft coupler that holds the auger in place. And just one final note about the auger. I'm using a 3/8 inch one, I believe, but you can also use a 7/16. But you don't want to use a half-inch one or one that fits perfectly in the barrel. You want it to be a little smaller than the barrel, because if you use one that fits perfectly, it looks cool, but it has a tendency to sort of catch pieces and bind. And so you want one that's a little bit shorter than the barrel, because its only job is to move the unmelted material into the barrel, not to actually extrude the melted material, which takes a lot more force. So that's step one, part one of this three-part series of how to build the trash printer. And if you'd like to see more of this, you would like to see more useful documentation for how to do or build open source things, please do consider supporting me on Patreon. It's patreon.com/disruptivelyuseful. And if you do that before New Year's, before the end of the year, you will be entered in a raffle to win this nice light up mushroom lamp that's printed out of trash. So thank you for watching, and I will see you next time.